Okay, this tutorial is covering the concept of ratio of coefficients, which is the conversion factor between moles of one substance in a reaction and moles of another. Okay, so keep in mind that the coefficients in a balanced equation, okay, so these big numbers right here, they tell us how many moles react and how many moles are formed. So in this balanced reaction, this coefficient of 4 tells us that we have 4 moles of aluminum that react for every 3 moles of oxygen to form 2 moles of aluminum oxide. So we could also say for every 4 moles of aluminum, we make 2 moles of aluminum oxide. For every 4 moles of aluminum, we need 3 moles of oxygen. Or for every 3 moles of oxygen, we'll make 2 moles of aluminum oxide, which is Al2O3. Okay, so we are starting with 0.120 moles of aluminum. Okay, and we're going to multiply that by the ratio of coefficients. So the coefficient in front of aluminum is 4. We're going to match the units on the top and the bottom, moles of aluminum. It's 4 moles of aluminum reacts with 3 moles of oxygen. So for every 3 moles of oxygen, we need 4 moles of aluminum. Now you're going to multiply the numbers on the top and divide by the numbers on the bottom. 0.120 times 3 divided by 4, you will get 0.09. Okay, we canceled out moles of aluminum. We were looking for moles of oxygen. Okay, how many moles of oxygen would be needed to react with 0.120 moles of aluminum? So if we're changing the amount of aluminum that we add into the equation, now how much oxygen are we going to get? Okay, and notice that we got a really small number, and that's okay because we started with a much smaller amount of aluminum than the original 4 moles that the recipe called for, or the reaction called for. Okay, and then if we want to take into consideration significant figures, change that to 0.0900 because we had 3 significant figures in the given, and your units are oxygen. Okay, in the next example, we're going to use the same balanced equation, but instead of changing the amount of aluminum, we're going to change the amount of oxygen in the reaction. So it says how many moles of aluminum oxide would be produced from 7.00 moles of oxygen. So if I put this much oxygen into the reaction, how much aluminum oxide am I going to get? Okay, start by writing the given. Whatever units you have on the top are going to go in the bottom of the next step. That is so that we can cancel them out. Okay, so moles of oxygen, moles of aluminum oxide. Okay, mole ratio. Since this is the ratio of coefficients, we're going to use the coefficients from the balanced equation. The coefficient for aluminum oxide is 2. The coefficient for oxygen is 3. For every 3 moles of oxygen we use, we'll make 2 moles of aluminum oxide. Okay, so you're going to multiply the numbers on the top, divide by the numbers on the bottom. You will get, going to round it to 3 significant figures, 4.67 moles of aluminum oxide. Okay, so whichever unit was left on the top is the unit that you're left with. Okay, and if you look back at the question, that was the unit that we were looking for, moles of aluminum oxide.